Hello statistics students, Mr. Cruzado. Let's take a look at the following data. So on the screen you will see a scatter plot. So this is actual data. One day when I cooked a ham, I put it in my crock pot. Down on the horizontal axis, the explanatory variable, I put time, and 0 represents 2 p.m. So I put the crock pot on at 2 p.m. And on the vertical axis we have the temperature. So the goal of this problem is to kind of put everything together from linear regression that we've been covering. So if you scroll down a little bit on your worksheet, you will see the following data. So let's pull out our calculator and enter the data. And my suggestion is you kind of follow along and do this with me to make sure you remember the processes. So remember, you pressed Stat and you moved over to Edit. So you press number 1, and then you're going to type in the data that you see on the screen. After you type in the data, and please pause the screen to type in the data, we press second y equal, and we press number 1. We put the scatter plot on, and you set up your screen like that, and then we pressed zoom 9. So when you press zoom 9, you get the scatter plot. To get the linear regression, we pressed Stat, we moved over to Calculate, we pressed number 8, we moved down to the regression equation, and we pressed bars, moved over to y bars, function, and then we pressed y1, and then we moved down to calculate and pressed enter. And there you will see the least squares regression line and the correlation coefficient. So let's write that information down. So on the screen you'll see the regression equation. Y hat is equal to a plus bx. So y is equal to, or y hat is equal to 11.6442 plus 0.7154x. And the correlation coefficient is 0.9976. Let's go to the next page. Now that we have the regression equation, let's interpret the slope and determine if the y-intercept has a meaningful interpretation. So we have 11.6442, and it would be my suggestion that you pause the screen and interpret the slope on your own, divided by 1, and then remember we put the units. So the y was the temperature in Fahrenheit, and the x was the time in minutes past 2 p.m. So the way we interpreted this was the following. On average, for every additional minute, the ham was in the crock pot, the temperature increased by about 11.64 degrees Fahrenheit. And I did add a little extra content since I knew the ham was in the crock pot and not the oven. Part B, does the y-intercept have a meaningful interpretation? So that means x is 0 and y hat would be equal to 11.6442. That means in this particular problem, when I started the crock pot, the temperature of the ham was 11.6442. So I think it does have a meaningful interpretation. So I would say yes. The ham's initial temperature was 11.6442 degrees Fahrenheit. Okay, let's do a little review question. Do you remember how to interpret the correlation coefficient? If not, feel free to look it up and write your answer down. So the way we interpreted this is there is a strong, and some people will use the word very strong, positive linear relationship between the time and temperature of the ham. Remember, the components were strength, that are underlined in red, direction, positive, we always say linear, and then we always want the context of the problem. Okay, let's take a look at letter D. What would you predict the temperature to be after 95 minutes? So there were two ways that we did that problem. One way we can do it is if we use the calculator and we were to hit graph, we press trace, then the scatter plot right now, the cursor is flashing on the dots, we press the up arrow key and we typed in 95. So when you type in 95, you get 79.61 degrees approximately. The second way that you can do that problem is, now that we have the equation, you could plug in 95 in for the value of x. So doing that on our calculator, let's see if we get the same answer of 79.61. So doing that, 11.6442 plus 0.7154 times 95. And when you do that, you'll notice you get approximately the same answer of 79.61 degrees. So the temperature after an hour, or excuse me, 95 minutes, is approximately 79.61 degrees Fahrenheit. Let's take a look at calculating a residual, which is the last part of this problem. So the last part of this problem, I want to calculate the residual at 3 p.m. That means it's been cooking for 60 minutes. And when I look at the chart that was given, 60 minutes is right here. The temperature was 53 degrees. So that was the point. That's how I got this point here. So remember, this is the x and that is the y. So the definition of a residual is equal to the actual minus the predicted. So it is the actual minus the predicted. So the actual temperature was 53 degrees minus the predicted, so I'm going to use my regression equation again. And I'm going to plug in 60. So we need to pull out our calculator and type that in. So when you type that in your calculator, and you can see I typed it in the top of the screen, double check I don't have any typos. And when I press enter here, I get negative 1.5682. So negative 1.5682 is the residual. And if you remember, that means the point is below the line. So this video's intent was to summarize Unit 7. We also reviewed Unit 6 in typing in the data in the graphing calculator, and we reviewed interpreting slope in the y-intercept.